Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 74th Project Euler problem. As always, I will link to both my repo and the problem in the description. Let's dive in. Problem 74 is digit factorial chains. The number 145 is well known for the property that the sum of the factorial of its digits is equal to 145. Perhaps less well known is 169 in that it produces the longest chain of numbers that link back to 169. It turns out that there are only 3 such loops that exist, and then it lists those. It is not difficult to prove that every starting number will eventually get stuck in a loop. For example, here's 3 loops. Starting with 69 produces a chain of 5 non-repeating terms, but the longest non-repeating chain with a starting number below 1 million is 60 terms. How many chains with a starting number below 1 million contain exactly 60 non-repeating terms? Okay. So, in order to solve this, we will probably have to go through all of these starting numbers and calculate these chains. So let's go ahead and get started. Add our date time function so we know for sure how long it took to run the program. And then I'm going to do a limit of 1 million. And then basically what we need to do, and this is the most naive approach, but what we can do is we can say for n in range 1 to limit plus 1, so we include the limit. Oh wait, no, we starting number below 1 million, so we actually don't want to include the limit. Calculate length of chain. Okay, so I'm just going to say num60. Start at 0. Okay. Oh, right. Because I need to write some code here. Okay. So, something that we can do here, we probably want a method to calculate the next number in a chain. So, and actually, I think to terms is going to be a dictionary of a number to the number of terms found in the chain starting with that number, and we can use that to reduce our number of calculations. And then I think we should also have to extend. So when we calculate the next number, we add that to a dictionary as well, and that should also reduce our calculations. Two. Okay. So I don't know if 145 is the only number that is like that, but let's see. Yeah, the first time we find a number that previously existed in the chain. Okay. That's going to be the function we write. And then it's going to be while next in, not in chain. And that might not be super efficient, but most of these are going to not be very long. So yeah, this may or may not be the bestest way to do that, but okay, so this is basically going to ignore this part for right now. I'm going to go ahead and put this as a limit of 100 at first, just so we can sort of see it working. Okay, so first, we want to do and then we want to return the sum of it happens to be a factorial method. So So I'm just going to do that for right now. Have to convert it back to a digit after you convert it to a string, of course. Okay, so 1, it goes back to 1. 2 factorial is 2, so this makes sense. 3 factorial is 6. So this should continue. And so the while loop does not appear to be working quite the way we want it to, perhaps. Because this should go on to 720. Interesting. It only goes through it once. Ah, that was my error, as I was calling it with n every time. That makes sense. Let's try that again. Okay. This appears to be working. So now we delete this print. And again, these two items were meant to help reduce the number of calculations we have to do, but it looks like for small limits, that doesn't make much difference. So, limit of 1,000, 10,000. Okay, we're already getting up close to a second, so let's go through with 100,000. Okay, maybe this very naive approach is just going to work. I have a feeling not, though. I have a feeling it's not going to finish within a minute. So, let's go ahead. Have this be first. Okay, so It did run in under a minute, but it didn't find any, even with a limit of 1 million. So, something is not quite right here. Let's double check our chains here. It appears it skipped 2 and also 9. That's weird. Let's grab all of these samples. So 145, 169, 69, 78, 540, 871, and 872. Just going to make sure these all look right. Quick. Okay, so 145 should just be 145. 69. We got 363600, 1454, 169, 363601. 1, 2, 3, 4. Yeah. 1, 2, 3, 4, 5. Okay. Oh. Well, I'm never exactly increasing the number 60. So if the length of the chain equals 60, which I'm actually... No, I'll just leave that. Num60 plus equal to 1. Okay, so now let's see how many we get. Now, it is still going to take most of the minute, I think. Actually, yeah, let's leave that for right now. Okay, so if we do literally just that, it might increase our speed quite a bit. So 402, and that took 43-ish seconds. Let's see if it slims down the time just adding that little lookup. Yeah, that is dramatically faster. So, using a dictionary to store data so that we don't have to do calculations repeatedly is a good tactic. So now let's go ahead and see if that's the correct answer. And it is. So there we go. So in this particular case, a relatively naive approach worked just fine. We did add a little bit of an optimization here, but all we're doing really is we are manually holding in memory all of these numbers, starting with the number n, and then we are finding the sum of the factorial of every digit in n to calculate the next number. We're saving it in a dictionary so we can just look it up if we come to that number again. And then we just sort of have that in a while loop so we can keep going until we found the first repeating term in the chain. And then checking whether the chain length is equal to 60. If it is, we up our counter. And then after we go through the loops, we show what that number is. So, pretty short for this one. I'll call it a day there. And as a reminder, if you would like to get my help with any code challenge you might be working on, please check the link in the description. I'll see you in the next one.